Hi, grade 7th. This is our next section on solving algebraic expressions using our X box. What we're going to do in this session is we're going to start to show how we can use our X boxes to help us learn some rules for isolating our variable X in an algebraic equation. So let's do some warm-up first. Let's use our X boxes the way we did in the previous session, along with our pennies. So here the equation says 4x, so we're going to need to use 4 X boxes. So let's put 4 X boxes in our working space here. There's 4 X boxes. And it's 4x plus 3 equals 11, so we need 11 pennies. Okay, there's our 11 pennies. So now we have an equation here, 4x is equal to 11. Okay, so what was our rule? We knew that we didn't put constants in our X boxes, so we had to take those constants away. So we have 3 pennies that are constant. So what we're going to do is we're going to take those away as usual. 1, 2, 3. Okay, so we took those away, and the remainder of the pennies we have to fill up our X boxes, making sure there's an equal number of pennies in each box. Okay, so each X box has 1. And we put the last of the pennies in, and we can see that each X box has 2. So going back to our whiteboard, we can write X is equal to 2. Okay, so that's what we did in the previous session. Continue to look at our whiteboard. Let's do another one, and let's see what we do, how we can show on paper what we're doing with our X boxes. Okay, so here we have 2x is equal to 10, so we want to put out 2 X boxes, and we're going to need 10 pennies. X is equal to 10. So of course we know that we don't have any constants, so we can just start filling up our X boxes, making sure we put the same number of pennies in each. And let's take 1 X box away because we want to know what each X box is equal to, and there's 5 pennies in that X box, so we could write X is equal to 5. But looking back at what we did, we actually took those pennies and we split them up into 2 X boxes. So what we really did is we took 2 X boxes and we divided those by 2. So instead of looking at 2 X boxes, we really divided those X in half, because at the end we're really looking at 1 X box. And that 1 X box, looking at your screen, now has X is equal to 10 over 2, or X is equal to 5. So relating this to operations, what we really did is we divided both sides by 2. And we know that 2 divided by 2 is equal to 1. So really what we have here is 1 times x equals 10 divided by 2, or x equals 5. Okay, let's try another one like that. Three x equals 9. So we need 3 x boxes is equal to 9 pennies. Okay, so again what we're doing is we're taking pennies and we're dividing them into 3 x boxes. We're taking the 9 pennies, dividing them into 3 x boxes. So looking at our screen, we're really going 9 pennies, dividing them into 3 x boxes. And for our answer, we're only looking at 1 x box, so let's take the other 2 away and see how many pennies are left. So we know 3 divided by 3 is equal to 1. So 1 x box has 9 divided by 3 pennies, or the x box, 9 divided by 3 is equal to 3. Okay, so this is how we show on paper what we were doing with our x boxes and our pennies. Let's take a look at another example. Let's say we have 5 plus x is equal to 8. Let's set this up. We only have 1 x box, and it has to be equal to 8 pennies here. Okay, so that represents our x blocks plus 5 is equal to 8. Now, 5 is our constant. So what we did is we took away 5. 1, 2, 3, 4, 5. Okay, I'm going to leave those there for a minute, just inside. So they're not really part of our equation, but we can't just take them away like we were doing. We have to put them somewhere. Where do we put them? Well, when we took them away, we really subtracted 5. So showing this on paper, we know 5 minus 5 is 0, plus x is equal to 8 minus 5 is what we've got left over here, and that is 3. So our equation becomes 0 plus x is equal to 3. And we know 0 plus x is x, so we have x is equal to 3. Because now we have those 3 pennies left. There's only 1 x box for them to go into. So we would have 3 pennies in that x box, or x is equal to 3. Okay, so again what we did is now showing what we did using our manipulatives, and we're showing the math for what we're actually doing. And what this is called isolating x. And why is it called isolating x? Because we now have x by itself on one side of the equal sign. Okay, let's do a little bit more complicated one here. We have 2x plus 7 equals 13, so we need 2 x boxes and 13 pennies. 3, 5, 5 is equal to 13. 3, 6, 9, 12, 13. Okay, so we have 2x plus 7 is equal to 13. Now the first thing we always did is remove our constants first, and our constant is 7. But now we know we just can't remove it. We have to actually, when we're subtracting it, 2, 3, 4, 5, 6, 7, they don't go away. We actually have to be fair to subtract it from both sides. So we're subtracting it from one side, we're subtracting it from the other side, and now we can take them away. We've dealt with them, we've subtracted them from both sides. But let's look at the math we did. We now have 2x plus 7 minus 7, and we know plus 7 minus 7 is equal to 0. So right now we have 2x plus 0 is equal to 13 minus 7. That's what we just did with our x boxes. Well, we know 2x plus anything plus 0 is itself. So we can write 2x is equal to 13 minus 7 is the number of pennies that are left here, and there are 6 pennies left here. Okay, in the second step, we know we have to take those 6 pennies and we have to divide them evenly into our x boxes. So really, we're taking these pennies and we're dividing them into 2 x boxes. So what we're really doing here is we're dividing both sides of the equal sign by 2. So on our whiteboard we have 2x divided by 2 is equal to 6 divided by 2, and we know 2 divided by 2 is 1. So we could really write 1 times x is equal to 6 divided by 2, and we know 1x is just x, and x is equal to 6 divided by 2 is 3. The way we show that on our board here is by taking these 2 x boxes, we're dividing by 2, so we only have 1 left, and we can see that there's 3 pennies in that single x box. Now, remember yesterday I said you should be checking all of your answers by putting them back into the equation. And making sure, whoops, okay, I made that a little bit bigger here. Sorry, I didn't intentionally do that. We need to be able to take x is equal to 6. Sorry, it did make it too big. Darn it, I lost it. 6 over x is equal to 3, sorry. We need to be able to take that number 3 and substitute it back into our original equation and make sure that we get the same answer. So let's do that. We have 2 times x is equal to 3, so we substitute 3 in for the 2, plus 7 is equal to 13. So using our order of operations, we do our multiplication first. Okay, so we're going to do 2 times 3 first. So 2 times 3 is 6, plus 7 is equal to 13, or 13 is equal to 13. So that is correct. So our answer, x is equal to 3, is correct. Okay, so we've done a bunch of questions in which we added constants. Let's see what we have to do in order to subtract constants. So let's try one here. 4x minus 1 is equal to 11. Let's set it up. So we have 4x and 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so there's 4x is equal to 11. Okay, so now we have to do the opposite of what we did when we were adding. So when we added, we realized a constant didn't go into one of the x boxes, so we took it away so that it wouldn't go into the x boxes. So here we have to do the opposite of what we did when we were adding. So we're going to have to, instead of taking 1 penny away, we're going to have to put 1 penny in. And how would we show this on math, using math? Look back at your board. What we're really doing is adding 1 penny to each side. So here we get 4x minus 1 plus 1, and minus 1 plus 1 is going to be plus 0. So that's going to give us 4x plus 0 is equal to 11 plus 1 is 12. Or 4x is equal to 12. So now we have 12 pennies and 4 x boxes, and of course we're dividing those 12 pennies into 4 x boxes, ensuring that the same number of pennies goes in each x box. Okay, we've now divided by pennies into 4 x boxes, and we want to divide those x boxes, so we only take 1 left. We have 1 x box left with 3 pennies in it. So we should be able to say x is equal to 3. Can we? Absolutely, because 4 divided by 4 is going to be 1. So it's going to be 1x is equal to 12 divided by 4, or x is equal to 3. Okay, let's check that by substituting back in. So 4 times 3 minus 1 is equal to 11. Using our order of operations first, 4 times 3 is 12. Minus 1 is equal to 11, or 11 is equal to 11, which is true. Therefore, our answer, x is equal to 3, must be correct. Okay, let's do another multiplication one. Here we have 3x is equal to 9. So we have 3 x boxes, 9 pennies. Okay, so this represents our problem. 3x is equal to 9. And we don't have any constants here to worry about. We always deal with the constants first, but there are none. So what we do is we just divide those x boxes, pennies, up evenly into our x boxes. Okay, so now we've got them divided evenly into 3 x boxes. And if we take 2 of those x boxes away, which is dividing x boxes by 3, we can see how many pennies are in that last x box, or x is equal to 3. So using the math, what we did is we divided both sides of the equation by 3, and we canceled out 3 divided by 3 because we know 3 divided by 3 is equal to 1. So we get 1x is equal to 9 divided by 3, or x equals 3. Let's check by substituting back in. 3 times substituting in 3 is equal to 9, or 9 is equal to 9, and that checks out. So our answer must be correct. Okay, now we're going to do the most complicated one of all. x divided by 3 is equal to 2. So again, we have to find out what x is. Now this is the most complicated one for a reason. We only can work with one x box. Because notice there's no coefficient. Coefficient, remember, is the number in front of your x. There's no coefficient there. What we really have is x divided by 3 is equal to 2. So using our rules, we know we have to start with 2 pennies. So what we're really saying here is somehow we have to figure out x and divide it by 3 to get it to equal to 2. So what we need to do is we actually need to take that x box, and we need to take that x box and divide it into 3 parts. So let's do that using a marker. Okay, so now I've got my x box divided by 3, and I know my x box divided by 3 has to equal 2. So what that equation is telling me is that this section of the x box has to equal 2. But we know with x boxes everything always has to be equal, so those other 2 sections also have to have the same number of pennies. Okay, so if one section of that x box has 2 pennies, then the whole x box has 1, 2, 3, 4, 5, 6 pennies. So x is going to be equal to 6. So what we did in math is we really multiplied that x box by 3, and we multiplied the 2 pennies by 3, and we know 3 divided by 3 is 1. So we get 1x is equal to 2 times 3. 1x is the same as x is equal to 6. Of course, we do our check again, and we substitute in. So we're saying 6, we substitute in for x, divided by 3 is equal to 2. Or 6 divided by 3 is 2 is equal to 2, which is a true statement. Therefore, x equals 6 must be the correct answer.